So today we're going to cover Chapter 5, Section 6. Today we're going to learn our last two shortcuts, and the acronym for those are ASA and AAS. So ASA stands for angle, side, angle, and AAS stands for angle, angle, side. Notice they both have the letter A and one S, but the location of that side congruency is going to be what's important to us, and you'll see the difference. So the first one is the angle, side, angle, and this is a typo. This should be the word theorem. It's not a postulate. In our older textbook, it was called a postulate. Again, when you're using these shortcuts as reasons in your proof, all you need to do is give me the acronym. So if this is going to be a reason in your proof, all you have to put is ASA. You don't have to tell me that it's the congruence theorem. So what the ASA congruence theorem states is that if two angles and what's important here is the included side of one triangle are congruent, and the two angles and the included side of the second triangle are congruent, then the two triangles are congruent. So what this means is it's going to be the side that's in between the two angles. So it's going to be between the two angles that are given as congruent. So it has to be the included side to use ASA as a reason. So these two triangles, again, the order matters. So if I start out by saying what triangle is congruent to ABC, you got to match the markings on the angles. So this would be triangle DEF. And the reason would be angle, side, angle. Now, and this is what's going to lead us to the next slide, if I took the same two triangles, ABC, and then the DEF, if I left the markings at the same spot, A to C and D to F, but this time, if I put the marking of the congruent side over here, then it's not in between the two angles. And this is going to lead us to the next shortcut, and this is going to be an angle, and a side. So when I move the side congruency mark to not between, not the included angle, then it's going to be the angle, angle, side, which is described on the next slide. Order for angle, side, angle, the angles have to have the side that is marked in between them. So again, here it would have the A, then the side, then the A. So the side has to be in between the two angle congruency mark for ASA. So here we go. Here's the official angle, angle, side. So this one states that if two angles and the non-included side, so it can't be in between the two angles of one triangle are congruent to two angles and the corresponding non-included side of a second triangle, then the triangles are congruent. Notice in the picture here, this side is not in between these two angle marks. So it's an A, and then it gets to the side. So AAS, it's not in between the two angles. So pretty much whenever you see two angles that match up and a side, they're going to be congruent. You just have to decide, are you doing ASA or are you doing AAS? The location of that congruency mark on the side is what makes it different. So again, the congruency statement here would be triangle GHJ is congruent to triangle KLM. And this is using angle, angle, side. Next slide just summarizes all 5 shortcuts or methods that we've learned. First one, side, side, side. Remember that all 3 sides are congruent. One is side, angle, side, and this shows that the 2 sides and the included angle are congruent. And then the last one, the third one, this is only for right triangles, and that's the hypotenuse leg. So as soon as you establish you have a right triangle, then you're going to look for congruency marks on the hypotenuse and one of the leg pairs. And then the last two are the ones we just learned, angle, side angle, two angles in the included side, and then when it's AAS, that's angle, angle, side, and that one is the non-included side. So these are the 5 shortcuts or ways that you will prove that two triangles are congruent. So here is our first proof. I'm going to go ahead and set up my statements and my reason columns. I'm going to start listing all of this given. Angle X congruent to angle V. Angle YZW is congruent to YWZ. And segment or side XY is congruent to VY. And this reason is given. I'm going to label all of this in my picture. So X and V are congruent. And then I also have angle YZW congruent to YWZ. And then the segments. I have XY congruent to VY. What I'm trying to prove is that this triangle over here on the far left, the XYZ, is congruent to the triangle on the far right, the VYW. Notice right now in the picture, I only have 2 congruency marks on my picture. There are no right angles in this, so obviously hypotenuse leg is out. So I need to come up with another angle that is congruent here, because obviously I'm not going to be able to get all 3 sides. So what I'm going to establish is that I have a linear pair going on here. So I'm going to state that this together is a linear pair, and so are these two together. That's going to be my next statement. That's what I'm going to focus on. So I'm going to state that angle X, Z, Y, and angle Y, Z, W are a linear pair. And I'm also going to do the other pair in the same statement. So this group over here. So these are the 2 linear pairs I'm talking about. So the next one is angle YWV and angle YWZ are also a linear pair, both of these. And this is definition of a linear pair. Next, I'm going to state that these are supplements, and that's my linear pair postulate. So I'm going to now state that same thing, XZY and YZW, and then the other pair, YWZ, both of these pairs are supplementary, so they're supplements. And that's my linear pair postulate. Or you could abbreviate it as LPP. Next, I'm going to state what it means to be supplementary. And I'm going to say that angle XZY plus angle YZW equals 180. And then the other ones, YWV plus YWZ equals 180. And this is definition of supplementary. however you want to say it, since both of these equal 180, I could cross off the 180s and set these two equal to each other. So I'm going to state that angle XZY plus angle YZW is equal to the other pair, YWV plus YWZ, and this is either, you can say it's transitive, because the 180s canceled out, or you could say substitution. More than likely, when you're doing homework, they're going to use transitive. They're not going to use substitution for something like this. Next, what I'm going to do is another substitution. But what I'm going to do is, notice up here at the beginning, my given. I'm going to replace this YWZ with what it equals, which is YWZ. So I'm going to rewrite this. I'm going to take out what I underlined in green and replace it with what it equals at the beginning, which is the YWZ. The right side I'm leaving alone. I'm only substituting one thing. And this has to be substitution. You can't say transitive here. And now if you notice, on both sides, I have angle YWZ. So I'm going to subtract this from both sides. And now I'm left with angle XZY is equal to YWV. This reason is subtraction. And now, if I go back and mark these angles, now I have enough to prove these triangles are congruent, because now I have this angle congruent to this angle, and I can prove this by angle, side. So my last statement is what I was trying to prove, that triangle XYZ is congruent to triangle VYW, and the reason is angle, side. Next one's a little shorter. So again, we're going to make our two statement and reason. Okay, so let's set it up. Statements, and let's do it in black so it shows up better. Statements and reasons. Number one, JL bisects angle KLM, and angle K is congruent to angle M, and that's given to me. Now, the K and the M already have markings on it, but notice I can show that KLM here is going to be bisected, and I know an angle bisector splits it into two congruent angles. But not only do I have to label my picture, but I've got to state that in my proof. So I'm going to state that angle KLJ is congruent to angle MLJ. And this is definition of an angle bisector. Now, I still only have two pieces marked here. I need a third piece, and I can do the reflexive side, the obvious. I could do this side here in the middle, and I can state that side JL is congruent to JL. That reason is reflexive. And now notice in your picture, you've got an angle, and a side marked on both. So we can now state that these two triangles are congruent. JKL is congruent to JML, and this reason is angle, side. It's not the included side, it's the non-included side. So that's why it's AAS. Okay, so for this one, We're going to identify which theorem or postulate proves that triangles are congruent. We can use any of the 5 shortcuts we have learned. So let's go ahead and take a look at number 1. So the 2 triangles are here. We have this blue one here, and then this red one. And then we have angle 150 here, and it's marked as congruent to this one. Then I've also got this side that they share marked as congruent, as well as the angle 15s over here. So you can see that this has got an angle, the included side, and then an angle that's marked on both. So this is yes, and the reason is angle, side, angle. For the next one, notice that they've written it as 90 degrees here, but this is a little right angle here. I've got congruency marks on the sides across from the right angle, making this hypotenuse congruent to this hypotenuse. And then I also have congruency marks on the legs. So for this one, I could use hypotenuse leg. However, if you were writing a proof, we could also establish that this side here in the middle, this reflexive side, is also congruent. So we could also, on this one, say side, side, side. And because we also learned a theorem that all right angles are congruent, we could also use side angle side here. So we could also say that this side, this angle, this side on both, and use side angle side as well.
Is the side theorem always applicable to right triangles?
Not necessarily. It depends on.
Can you use the hypotenuse leg? Can you also use the side?
It depends on how they're positioned. If they're attached like this, yes. But if they're not attached and we don't know anything about that other leg, then not necessarily. So it's going to vary on how they're sitting. Does that make sense? All right. So this one was all 3. Again, that always doesn't happen, only sometimes. All right, let's try number 3. So notice we do not have an indication here telling us that these are right angles. We don't know that for sure. It looks like they are, but we don't know it. We do know that this reflexive side is congruent to itself. So this one could be side, side, side because of the reflexive. However, we also have vertical angles going on here. So since this angle is congruent to this, because they're vertical, and this had the same marking, for this one, we could also do side, angle, side, because both of them have the same marks. So this one would also be side, angle, side. And then we have one more proof, and then we're done with the notes. And here's our last proof. So let's set up our statements and our reasons. This one's a little long as well. It's going to be very similar to the other one. So statements and reasons. Number 1, let's restate all of this given. So angle FAB is congruent to angle GED, and angle ABC is congruent to angle EDC. And we also know that AC is congruent to EC. So let's state this as our given. And let's label the picture as well. So I know that FAB is over here, and it's congruent to GED, which is over here. I also know that angle ABC, this one up at the top, is congruent to EDC. And then side AC is congruent to EC. So what they're asking me to try to prove here is that this triangle ABC is congruent to this triangle here, EDC. So right now, the way it's pictured, both of the triangles only have 2 markings. So we need to get a third congruency on here to prove them congruent. So again, I'm also going to establish that linear pair again. So I've already just labeled my given. I need to find another piece. So I'm going to do the same thing that I did on the other one. I'm going to establish that I've got a linear pair going on here. So over here, I've got a straight line, and this one, so I'm going to talk about this linear pair group here. So I'm going to establish just like I did before, and I'm going to state that angle FAB, which was already given to me as being congruent, and along with the angle on the other side of it, plus CAB there. This is a linear pair. Actually, I'm going to do the other pair as well, so I'm going to say R a linear pair. R a linear pair. And then the other one on the other side over here that I underlined in pink. I'm also going to say angle GED along with CED. This is another linear pair. And this is definition of a linear pair. Next, I'm going to state that a linear pair supplements. So I could state that angle FAB and CAB and the GED, same thing that I wrote up above. Now, instead of stating that they're a linear pair, I'm going to say are supplementary. And this reason is the linear pair postulate. Next, I'm going to establish what it means to be supplementary. And I'm going to say that angle FAB plus angle CAB equals 180 degrees. And GED plus angle CED equals 180. And this is definition of supplementary. Next, because they both equal 180, I'm going to set these two equal to each other. So angle FAB plus angle CAB equals the other linear pair, GED plus CED, and I did transitive. And again, you could also call this one substitution. But again, when you're doing the homework, more than likely it will be listed as transitive. And now what I'm going to do is another substitution, because up at the top, we were told that CED, let's see, replace FAB, let me do it in green so it shows up. Since FAB equals GED, I'm going to take out this GED and I'm going to replace it with FAB. So I'm replacing this with FAB. I'm going to rewrite everything else that's right above this. So I'm doing a substitution. Because I substituted GED with FAB. And now what I can do is subtract out the FAB from both sides. So this would be subtraction. And I'm left with CAB is congruent, these are all equal, congruent to CED. So this reason is subtraction. So let me go up to my picture. So now I can label CAB up here as being congruent. Right here, 1, 2, 3. And then this one. And now I have enough things labeled in my picture to do angle, angle, side. So my last statement is triangle ABC is congruent to triangle EDC. And that's angle, angle, side. And that is it for the notes on 5.6. And this is the last of our 5 shortcuts.